Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first 5 problems of Codeforces Round 894, which was written for Division 3. So I believe today's F problem was totally solvable for me, like at my current level, but I was out of practice and I didn't do any problems on Codeforces for a very long time. That is why I believe my implementation was rusty and I made one wrong submission and later I couldn't complete my implementation. So anyways, we're just going to discuss the first 5 problems and let us quickly start with the first problem. So the problem statement is pretty big for what the problem says, but I'm just going to tell you this particular problem in a very simple manner. So you just need to take care of this particular string, that is Vika, V-I-K-A, right? So let me just tell you what the problem says. The problem says that you will be given a double dimensional grid, something like this, and then you have to search for the word Vika in it, right? But how you exactly have to search is something like this. Each column, for example, this particular column will be having some words, right? So it can have some characters like A, B, C, D, E, F. So this particular column does not contain the character V. That is why I'm going to look at the next column, right? If this particular column at any position contains V, right? So it doesn't matter where it is present, it should be present in this particular column, right? If it contains V, then I can move on to the next column and start looking for the next character, that is I, right? So if I find, let's say, I here somewhere and then K somewhere here and then A somewhere like this, right? So the answer will be yes in this case. Otherwise, if I cannot find all the values V, I, K, A in this particular order, so in that particular case, the answer will be no. So I've written all the 4 characters in consecutive columns here, but it is not at all necessary for them to be in consecutive columns. For example, if V was here, then it would have been totally fine as well, right? The answer in that case will also be yes. So our goal is to find this particular string Vika, and it should be present in such a way so that all the characters are in order, right? Order means that V should occur before I, K, N, A, and then I should occur before K, N, A, and so on. And the character can be present in any row of that particular column, right? So this is how you had to find this particular string Vika. Now you can implement it very easily by just doing brute force. So if I just show you my summation, so you see what I've done is I've taken 2 integers n and m, and I've taken a double dimensional vector of size n cross m. So the vector will be of characters. Now I take input in the vector and I have created a string called need, which is equal to Vika. Now I initialize my index with 0 and I'm just going through all the columns starting from 0 to less than n. For each column, then I'm just going through all the rows, and if that particular character is equal to the character that I need, I'm just going to increment my index and I'm just going to break from here, right? If I find that particular character, that means I should move on to the next column. Now at the end, if index is equal to 4, that means I have traversed all the characters of this particular string. In that case, I can print yes, otherwise I'll have to print no. So this would be the solution for the first problem. Now let us have a look at the second problem. So this particular problem was sequence game, and it says that we have been given a final sequence B, right? So B is something like this. Now B was created by following certain rules, and we have to find one possible sequence A from which B could have been formed, right? So if the size of B is n, the maximum size of A can be 2n, right? So this is a condition. Now I'll tell you the rules. What are the rules to form the sequence B? So I'll take some example from here. Just take this particular example, right? So this is the final sequence and we have to tell the sequence A from which this sequence was derived, right? So how do we actually derive this B from sequence A? Let us first understand the rules. So the rules are, we're just going to take the first character A1, right? And for all the remaining characters, I'm going to take A of I only if it is greater than or equals to A of I minus 1, right? So I'm going to take A of I if it is greater than or equals to A of I minus 1. Now by following this particular rule that I've just mentioned, I have been able to form this sequence B. Now I want to derive my original sequence A from this particular sequence. How do we do it? Let's say this is my final sequence, right? So the first place is 1 here. So the first place in the original sequence A will also be 1. right? Because we were taking the first character or the first integer as it is. So let's say this is sequence B and I'm writing the sequence A here. So the next number is greater than or equal to the previous number, right? So this could have been the case here as well. If in the original sequence 7 was present after 1, that means it was greater than or equal to the previous number and it was satisfying this condition. So that is why I could have directly put it here. So a possibility of sequence A is like this, right? 1, 7. Now for the next number, again it is greater than or equal to, so I can put 9 here. Now I see that this particular number is less than the previous number. So 5 could not have been here, right? Because if 5 was like this, then definitely this would violate this particular condition. Because now A of I, that is this particular number, is less than A of I minus 1. Right? If this condition is being violated, that means this particular 5 would have never been pushed to this sequence B. Right? So even if 5 was here, this 5 would not have gone to B. But what if I place one more 5 here? Right? So this particular character A of I is now equals to A of I minus 1. Right? And this particular 5 can go to sequence B and form 5 here. So this is exactly what we had to do. We just had to traverse sequence B. First of all, we just take B of 1, right? And for any index B of I, if it is greater than or equals to B of I minus 1, then we just write B of I as it is. Otherwise, we write B of, let's say, J. In this case, let's say B of J is less than B of J minus 1. We'll write B of J 2 times. Because this first B of J will be ignored while converting sequence A into sequence B. And the second B of J will be considered in sequence B. Right. So this is all you had to do in this particular problem. Now let us have a look at the code. So you see what I've done is I've created an integer n and I've taken input in the vector v of size n. Now I've initialized my answer vector with v of 0 and I'm just traversing through all the other values. If v of I is greater than or equal to v of I minus 1, that means it could have existed in the same way in the original sequence A as well. That is why I only push it one time. Otherwise, I'm just going to push it 2 times. Now I can just print my size of the answer vector and all the values of the answer vector. So now let us have a look at the third problem. So this particular problem required you to have some creative thinking and I'll tell you why. So the problem statement is fairly simple. It says that we have been given the heights of some fences. Now each fence will be in this particular order only. That means A of I will be greater than or equals to A of I minus 1 if we are going towards the right. Right. So it will be in non-increasing order. It can remain the same or decrease, but it will never increase. Right. So this is the order that they are following. Now if I flip it, by flipping I mean if I just place all the bars horizontally like this, then if both of these figures have the same identical structure, that means they are symmetrical. Now we have been given an array which is representing the height of these fences and we have to tell whether they are symmetrical or not, right? So this is the whole problem. So as you can clearly see with the help of this particular example, the fences are vertical here and the same fences are horizontal here and the final structure for both of them is exactly the same. In the second example, you can see that the fences are vertical here, the fences are horizontal, but the structure is a bit different in both of them. So that is why these array of elements will not be symmetrical. So let me just take some example. We're just going to discuss these two examples. Now let us first discuss this particular sample test case. So I'm just going to draw it very quickly. First of all, I have these 5 boxes vertically. Then I'll have 3 boxes. So it is repeated twice like this. And then I only have 1 box repeated twice. Right, like this. Now, if I place all the boxes vertically, so I'll have 1 box at the top and 1 box just below it. So I'm talking about these 2 fences. Now what I'll do, I'll have a box of width 3. So if I place it horizontally, it will be like this because they are twice. So I'm drawing both of them. And then for the final will be of size 5. Right. So you see, I drew the boxes in a different manner. These boxes were drawn vertically. The first is of height 5, then height 3, 3, 1 and 1. And then these boxes were drawn horizontally. This is of width 1, this is of width 1, this is of width 3 this is of 3 and this is of 5, right? But the structure is exactly similar in both of them. So how do we actually determine that they are going to form the same structure? So what I can do is, let's say I have the heights 5, 3 and 1. So first let me talk about height 5. I know that I have only one element of height 5, right? So I need at least one element of height 1. Why is it so? Because this particular width that I have here is going to be someone else's height. You see that this is the height of the boxes when I invert them horizontally, right? In this case the height was this, but in this case the height was this. So if my frequency of 5 is going to be 1, there should be at least some box whose height is 1, because this is extending only 1 units. Let's say I had 2 fences, right, of height 5. Now since this width is 2, I will need at least one element or one fence with height 2, right, to compensate for this. Now I move on to the next element, that is 3. Now the frequency of 3 is 2. So you will see that if the frequency of 3 is 2, that means they are going to extend till here, right? And what is the total width now? The total width is 3, right? So that means I need at least one element whose height is 3, because the width that I have here should be someone else's height. Only then when I flip them horizontally, it will become the width, right? Now I move on to the next value, that is 1. So when I come at height 1, I know that there are 2 elements of the same height, right? So this will add 2 to my width. So now the total width of this has become 5. That means there should be at least one element with the height is equals to 5. So I know this sounds a bit tricky, but let me explain you with the help of one more example and you will be able to understand. Before that, you just need to understand this particular fact that the height that we have here, when I flip them horizontally like this, right? So all of the heights that I have will become their width, and it will be vice versa as well. And now we are going to discuss this second test case. So what we do, let me just draw this very quickly. So if I have this particular grid, so I have 3 times the fences of height 5. Now I have 2 times the fences of height 3. So I'm just going to draw it like this. So now you will see that the only 2 heights that I have is 5 and 3, right? So the frequency of 5 is 3. That means this width is going to be 3, and that in turn means that the width that I have here is 3. Now I will need at least one element whose height is 3, and it exists. Yes, it exists. So that is no problem here. Now move on to the next height, that is 3. Now when I come to 3, I will observe, when I come to height 3, I will observe that the width at this particular point is 5. So that means I will need at least one element whose height was 5. So this was the correct mathematical way of thinking about this problem. Now let me show you the code and you will be able to understand this problem much more clearly. Now you will see what I have done is, I have taken an integer n and the input in a vector of size n. Now I have also initialized this frequency map and I am just updating the frequency of all the elements. So now what I do, I initialize my index with 0. This is for traversing through the vector, and I have initialized my current width with 0. Now the height of my current element is going to be v of index, right? And I need to calculate the width that I need. So that is going to be the width of my current element and the number of fences with the same height as the current height. What I am trying to say is, let's say the initial width was 0 here and I am trying to find the number of elements with the same height. So in this case it was 3, right? This is what I am trying to find, right? So in the next case, when the width was already 3, then I have 2 more elements with the same height. That is why in the next case the width will be 5. This is what I am trying to do here. I am trying to take the previous width and I am trying to take the frequency of the current height. After I have stored it somewhere, I can just update my width as width plus is equals to f of h, because the next time these elements are also going to be included. If the frequency of this needed width is equals to 0, that means I can just directly print no and return from here. Why is this so? Because there will be no element to compensate for the current width, right? Otherwise, if there exists at least one element, then I can continue. Now I initialize my current with index and I update my index by just incrementing it. So what I am doing here is, I am just trying to jump on to the next possible value of height. as long as the value of index is equals to the current element, I'm just going to update my index, right? So this way I'll be able to traverse through the whole array and I'm only executing each value once, right? So at the end, if I don't print no anywhere, I can just simply print yes, and that will be my final solution. So let me just move on to problem D now. So this particular problem says that we can make an ice cream by using exactly two. So those balls can be different as well as same. We can use any balls and they will form a flavor, right? So two flavors are considered to be different if the set of balls used in them are different. As you can see in this particular example, that 1, 2 and 2, 1 are not different because 1 and 2 are being used in them, but 1, 1 and 1, 2 is going to be different. So the idea is you can take any two types of balls, you can mix them together and make a flavor. They can be same and different as well. It's just that any two flavors which have the exactly same two balls are not different, right? Now we have to find the minimum number of balls needed to make exactly n different types of ice creams, right? So this is very important keyword here, that we need to form exactly n different types of ice creams. So basically ice cream means the flavors. We are not talking about anything different. It's just the flavors that we are talking about. So let us see what we can do in this. Now since my number of balls is unlimited, let's say I have n different types of balls. I can choose any two of them to make an ice cream, right, or to make a new flavor. So the number of ways I can do that is NC2. Now let us take some example from here. Let's take these two examples, 6 and 179. The answer for them is 4 and 27 respectively. So I'm just going to paste them here, and let's say the answer is 4 for this and the answer is 27 for this, right? So now if I do 4C2, you will realize that its value is 6, right? It is exactly equals to 6. That means I can use 4 balls because I have 4C2 ways of choosing the flavors from that, and that would lead to the total number of flavors being equal to 6. But what about forming 179 flavors? Let us try to take 19C2. If I calculate the value of 19C2, it comes out to be 171. Similarly, if I try to calculate the value of 20C2, so 20C2 is coming out to be 190. In the previous case, we were able to form the exact value, but here you see I am not able to form 179. So how do I exactly form it? Let us consider a small example. Let's say I have 1, 2, 3 and 4. So the total number of ways I can form ice creams or I can form different flavors from it is 4C2, and that we have already calculated, that is equal to 6. Now if I try to add the same value twice, let's say I add 1 here, right? So the total number of balls that I've used is 5, but the total number of flavors will only increase by 1, right? It is going to be 7 from 6. Now I'm not going to take 5C2 because these 5 balls are not all different, right? Because this 1 and 1 is repeating. Now you can observe by adding this particular one, my number of flavors have only increased by 1, and that is because this one is going to form a pair with this particular one, right? This is allowed, but this one cannot form a pair with this particular 2 and 3 and 4 because 1, 2, 1, 3 and 1, 4 already exists with this particular one. That means whenever I add a number which is already present among them, it is only going to increase the count by 1 or the number of flavors by 1. Now the question is, by how many times can I increase it, and can I form all the unique values with this particular method? The answer is yes, you can form all the unique values, and let me just prove it for you. So if I talk about n plus 1 C2 and n C2, right? So the difference between them is equals to n. What is the advantage of this particular formula? Now you see, if you do n plus 1 C2, let's say you were getting a value x, right? And if you do nC2, you were getting a value y. Now with the help of this particular equation, I can say that x minus y is equals to n, or x is equals to y plus n. So you are able to form y, you are able to form y plus n. The only thing you are not able to form is y plus 1, comma y plus 2, comma y plus 3, up to y plus n minus 1. Right? These are the values that you are not able to form. You can easily form these values by using 1 and then using 2 and then using 3 and then using n minus 1 at the end. So let me demonstrate what I am trying to say. If you already had 1, let's say the value of n here is 5. You already had 1, 2, 3, 4 and 5. Right. So you can form y plus 1 by adding 1 to the end. Right. So this way your answer will only increment by 1. Now you can form y plus 2 by adding 2 at the end. So this way again your answer will only increment by 1 because this particular 2 will not react with anybody else. It is only going to form a new flavor with this 2 itself. Now for y plus 3 I can make it 3. For y plus 4 I can make it 4. For y plus 5, since the value of n was 5, y plus 5 is already going to be equals to x. So I can form that particular x by doing n plus 1 c2. Right. So for that I don't need to add 5 here. I can just directly take n plus 1, that is 6 number of different or 6 number of unique balls. Right. And I can form y plus 5 from those 6 balls. Since 6 is the smaller value, I'll have to take that particular value. Right. So this way you will be able to form all of your answers. So this was the base idea of this problem. Now let us discuss how we can solve it. The first thing is you will have to find the greatest n such that nc2 is less than equals to the value that has been given to you in the input. Once you find this particular n, right, you will be able to determine, for example, in this particular case, you were able to determine that with the help of 19 you can form 171 values, right? So if with the help of 19 you can form 171 values, how many more values you need? So that is going to be equals to 179 minus 171 and that is equals to 8. So you're just going to add 8 to it and the answer is going to be 27. So this is how you can solve this problem. And to find the greatest value such that nc2 is less than equals to the value that has been given to us in the input, we can easily use binary search. So how we can use binary search? I'm just going to maintain an invariance condition. Let's say low, that means low c2 is always going to be true. That means it is always going to be less than equals to the value that has been given to us in the input, and high is always going to be false. So I can initialize my low with 0 and high with 2 into 10 to the power 9. Right. So now if I do binary search, I can just check whether the value of mid C2 is less than equals to the value that has been given to us in the input. That means I can set my low as mid and otherwise I'll set my high as mid. So what is the value of nc2? If I have been given any value n, I want to find nc2, it is going to be equals to n factorial upon 2 factorial into n minus 2 factorial. So this is effectively equals to n into n minus 1 by 2. Right, this is how you can calculate this value of mid C2 easily. Right, so let us discuss all of this theory in practice and how we can use all of this to solve this particular problem. So you see what I have done here is I have taken the integer n as input. I have initialized low with 0 and high with 2 into 10 to the power 9. I run my while loop for binary search and I calculate the value of mid. Now the value of mid C2 is equals to mid into mid minus 1 by 2. So if value is greater than n, then high will be equals to mid, otherwise low will be equals to mid. Now I calculate the current value as low into low minus 1 by 2. So this current is the number of flavors that I am currently able to form. So I'll just print low plus n minus current because these will be the extra number of balls that I need and low is the current number of unique balls that I have. So this would be my final solution, and let us move on to the final problem of this particular discussion. So this particular problem was also not very difficult. It says that we have been given some movies, right? So this is the array of movies and each value is denoting the entertainment value of that particular movie. So let me just discuss this particular statement only because this will help you to understand the problem. So you see what this is. Let me just make it a bit smaller. So if this is the entertainment array 3, 2, 5, 4, 6, and they're saying that I'm trying to choose this particular index and this particular index, right? I have been given a value d and that is equals to 2 in this particular case. So this is the entertainment value of each of the movies. By each passing day, the entertainment value of these movies will decrease by a factor of d. So they're saying that I watched a movie here at this particular point. Now when I go to this particular day, that means one day has passed. So the entertainment value of this particular movie will get decreased by 2 because the value of d is 2. So the total value will be 3 minus 2. Now I watch this particular movie. Now I go to the next day and I go to the next day. That means I watched this movie on the second day from watching this particular movie. So the entertainment value of this particular movie is going to get decreased by 2 into 2. So 2 is the number of days, the first 2 is the number of days, and the second 2 is the factor d. Right. So the final value or the total entertainment value is going to be 1 plus 1, and that is equal to 2. Right. This is what they are saying. Now they have also given us one more input, that is m, and that means we can choose at most m movies from this list of movies. So given these constraints that we can choose at most m movies, the entertainment value is decreasing by 2 every day, we have to find the maximum entertainment value that we can form from these set of movies. Right. So the very first observation is that, let's say you are taking these movies 3, 2, 4 and 6. Let's say you decide to take this particular and this particular movie and also 3. Right. So you watch the movie here. Right. When you go to this particular day, you are going to get a minus d because one day has been passed since you watched this particular movie. Now you come to this particular movie, you will get again a minus d. Right. Because now one day has been passed since you watched the previous movie. Now you go to this particular movie, you will get minus 2d. Why? Because 2 days have been passed. The first day here and then the second day here. Now let us say you watch the movie here and then you have 3, 2, 5 and 4 like this. You decided to directly watch this particular movie 4. Right. So from here you're just going here. Right. So what is the number of days? 1 and then 2 and then 3 and then 4. So now you're just going to get minus 4d directly. Here the total was minus 4d. Right. Here the total was also minus 4d. The observation in this particular case is that no matter how many movies you take, the decrement that you are going to face does not depend on the number of movies, but it rather depends on the last movie that you have taken. Right. So this value of the decrement that you will have to face because of this particular factor is going to depend on the last movie that you watched. So with the help of this observation, I am just going to try to form an algorithm which calculates the answer for me in a way such that for each I can find the answer if this was the last movie that I watched. Right. So I'll be traversing through all the indexes and I'll try to find my current answer if this is the last movie that I watch. Right. So how can I solve this particular problem? Now let's say I am at this particular index. So let me just remove this, and till this particular index there are 1, 2, 3, 4 and 5 movies. Let's say we are only allowed to have 3 movies. Right. So till here we have total 5 movies and we are only allowed to have 3 movies. The first thing is that the value or the entertainment of the movies can also be negative. We are definitely going to ignore those negative values. Let us only consider the positive values, and among those positive values, if I am at an index I, right, and there are total 5 movies till here, then I know anyways I am going to get minus 5d. Right. So if I am going to get minus 5d, let us confirm. That means I'll have to maximize the sum of the movies that I get. Right. So if I can only take 3 movies, I will try to take the maximum 3 movies among them. Right. Obviously ignoring the negative ones, I'll try to take the maximum 3 movies among them. So let's say movie at index 2, 3 and 4 were the maximum ones. So I'm just going to take all of these 3 movies and ignore the rest of them. Right. So this is how you can solve this problem. For every index, you have to find what is the maximum m movies that I have encountered till now. Obviously ignoring the negative movies. Right. What is the maximum positive m movies that I have encountered till now? I have to take the summation of all of them and then I have to subtract this particular value from it, that is equals to index into d. So how can I find the maximum m movies that I have encountered till now in constant time? I can use something like a priority queue. So how will I maintain a priority queue? I'll try to maintain a min heap. What is the advantage of min heap? With the help of min heap, I know that the minimum value is always going to be at the top. So whenever the size of my priority queue or my min heap becomes greater than m, in that particular case, I'm just going to pop the top element. So that top element will be the smallest element among those m plus 1 elements. So if I pop that particular element, the remaining elements will be m and those elements will be the maximum elements. So I'm trying to maintain the maximum m elements in this priority queue, and that is how I can solve this particular problem. So how do I keep track of sum? At each instant, I'm just going to increment my sum by v of I, let's say, right? And whenever this size of PQ, let's say size of PQ becomes greater than M, I'm just going to pop the top element from the Q, and I'm just going to subtract, before popping the element, I'm just going to subtract the top element from my sum variable. So in this way, I'll be able to have the sum of the top M elements in my sum variable at all times. And I know that I have to decrease this particular value, so well, I will always decrease this, and at each step I can take the maximum value of my current answer and my already existing answer. So let me just show you my final code what I submitted during the contest. So you see what I've done here is I've taken three integers n, m and d as input. I've created a vector v of size n, and I've also created a priority q. Now in C++, this is how you can create a min heap. By default, C++ forms a max heap. So if you want to create a min heap, this is the syntax that you will have to follow. Now I initialize my answer and some variable with 0. Now I'm just traversing through all the values, and I only consider one particular value if it is greater than 0. I add this particular value to my sum, and I push this particular value to my priority queue. Now if the size of my priority queue is greater than m, then I can subtract it from my sum variable and I can pop it from my priority queue. Now I can update my answer as answer comma sum minus I plus 1 into d. So I have taken I plus 1 here because I am using 0 based indexing. Now at the end, I can just print my answer, and that will be the solution of this particular problem. So that was it for today's contest. I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this particular video was helpful for you, and you'll be able to reach much more people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost, and you can always unsubscribe if you don't find the videos interesting later. So share this channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.